Good evening, Princess. I trust you are good. Yeah, so we're trying to solve this question 8.3 yesterday and we didn't finish it. So it's a very simple question. So here they said that the equation of the tangent to f of x equals, okay, the equation of the tangent to function f of x equals 3x squared plus bx plus c at x equal to 1 is given by y equals 9x minus 9. Now they said we should solve for the values of b and c. Now let's try to sketch the curve for the function f of x. Since the coefficient of x squared here is positive, then the shape of that graph would be like this. It will be a U shape. Now they said that there is a tangent to this curve or to this function. Remember, this function, this curve is f of x. So it's f. So let's just put f there. And you might put x in bracket. So this is the curve for this function. Now, they say that the equation of the tangent, remember, tangent is a straight line that touches the graph at one point externally, right? You can have two tangents here. The tangent can be on this side and the tangent can be on this side as well. Now this is the equation of the tangent, right? It's a straight line, and if you look at it, the gradient of this tangent is positive. If the gradient of the tangent is positive, then this tangent is ruled out because this is a negative line. I believe you know what I'm saying. This is a negative line, so we clean this. So it means the gradient, it means the tangent will be somewhere here. And they gave us a clue in the question. They said that the equation of the tangent, the equation of this tangent, right, at x equals 1. So x equals 1, let's say it's here, right? So at this point, x equals to 1, right? The coordinate of x there is 1, but we don't know the coordinate of y. So let's just say y there. So here we can know the coordinate of y because this point where x is 1 is on this tangent, it's on this straight line. Then we can combine these two coordinates, substitute it here, and find the corresponding value of y. So here y will be equal to, so all we need to do is to substitute 1 into this equation, and if we substitute 1 here, we end up with a y value of 0. So there we can change this y to 0. So the coordinate of y at that point is 0. Very good. So we are getting there now. So next we come here. Since this point where the coordinate of x and y are 1 and 0, since the point is also located on this curve of f of x, then we can substitute x and y into this equation. So doing so, this f of x, which is y, is 0. Then that will be equal to, if we substitute x equals 1 here, so this will be 1 squared times 3, that is 3. Then plus b multiplied by 1, that would be b. Then plus c. Right, so that will be the first, we can say, equation 1. Now one thing we can do here is we can find the first derivative of this f of x. So that will be f prime, right? F prime of x, the first derivative. And remember, the equation of the first derivative is the equation of the gradient. So that will be equal to 6x. I don't need to waste time here, right? You know this already. Then plus b. Right? So that is that. Now remember, this equation f prime, the first derivative, is the equation of the tangent, right? So this is sometimes confusing. Should I set it to 0 or should I set it to something else? You only set this first derivative to 0 if you are looking for the x coordinate at the turning point, right? So if your task, or if you are aiming, or if you aim to calculate the x coordinate at this turning point, that is when you set this first derivative to 0. But that is not what we want. We don't want x coordinate at the turning point at this point in time, because the question does not say that. So, and remember, this first derivative, let me write it there, represents the equation of the gradient. The equation of the gradient. Right, that is the equation of the gradient. So now, since the gradient has this formula, y equals 9x minus 9. Now, if you look at this very well, you will see that the gradient here is 9. So you can equate this equation of the gradient to 9. So that is equal to 9. Right. So easily we can say 6x plus b equal to 9. Now at this point we can substitute again this x equal to 1 into this. So if we substitute x equal to 1 into this, we have 6, right, times 1, which is 6, plus b equals 9. So that implies that b equals 3, right? Then we can go back to this equation 1 and substitute b equals 3 into this equation 1. So this is 0, right? So it means 0 will be equal to 3 plus b, and our b here is 3, right? Then plus c. So you could see c from here will be equal to -6. So that is the solution to that problem. If you have any other question, you can let me know. All right, cheers.